In this video I'm going to look at exponential sequence, and can you just look at the top of the green line first, okay, so ignore what's underneath it. Right, an exponential sequence, you might be forgiven for thinking it's just doubling or tripling, okay, and actually in the junior cert you'll get away with thinking that, right? So if you see a sequence like this, 2, 4, 8, 16, in your head you're going, well, that's doubling, every term is getting multiplied by 2, okay? And if you said that that's exponential, you'll actually get away with it, right? You get your marks. Likewise, this one has been multiplied by 3, okay? 3, 9, and then 27. So 9 multiplied by 3 is 27, 27 multiplied by 3 is 81. Okay. But what's actually happening is an indices, right? So watch. We take our first term and we put it to the power of 1. So 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. And 2 to the power of 4 is 16. So really, that's our sequence, right? 2 to the power of whatever. Okay? Likewise this. 3 to the power of 1 is 3. 3 to the power of 2. 3 to the power of 3. 3 to the power of 4. Okay? So while we'd be forgiven for thinking it's basically multiplying by 3 all the time, it's actually not. Okay? It's an indices, right? 3 to the power of 1, 3 to the power of 2, 3 to the power of 3, etc. Okay? Now, underneath the green line, here's a geometric sequence. For junior cert, we don't need to know about geometric sequences, okay? But just to show you the difference between exponential and geometric. Geometric is doubling or tripling, etc. So watch. 5, and then we multiply it by 2, we get 10, and we multiply that by 2, we get 20, multiply that by 2, we get 40, multiply that by 2, we get 80. Okay? There's a geometric sequence. 2 multiplied by 3 will give us 6, multiplied by 3 will give us 18, multiplied by 3 will give us 54, multiplied by 3 will give us 162. Again, there's a geometric sequence. Now you could be forgiven for saying, well, actually, this up here, so these two sequences on the top, okay, the 2, 4, 8, 16, and the 3, 9, 27, 81, you could be forgiven for saying they're geometric, okay? They could be geometric, alright? And I suppose just moving on from that, the only difference between this as a geometric sequence and an exponential sequence is that if it's an exponential, well then it's continuous, okay? Which means that if I was to draw it, okay, on a graph, it would be a line, okay, and that's the shape it takes on. However, if I was told it was a geometric sequence, well then I would be drawing it like this, okay, because geometric series are discrete. Okay, now we don't actually need to know that for junior cert. All we need to know is about exponential sequences and that they take on this form, but generally if you look and see that it's doubling or tripling and say it's exponential, well then you'll be fine. Alright? If we look at the geometric sequence though, right, how would I know that this 5, 10, 20, 40 is not an exponential? Right. Let's see. This is doubling, isn't it? Okay, 5, 10, 20, 40. Now watch. 5 to the power of 1 is 5. 5 to the power of 2 is 25. 5 to the power of 3 in 20. Okay, it's 125. So that can't be this 5, 10, 20, 40. Even though it's doubling, it's not exponential, because exponential would be 5 to the power of 1, which is 5, 5 to the power of 2, which is 25, okay, and 5 to the power of 3, which is 125. So do you see the difference? Right. Just to recap though, we do not need to know for junior cert about this we just need to be looking out for arithmetic, quadratic, and this one, exponential. And if we see the doubling or the tripling, well then we can say, okay, it's exponential, right? But just to be aware that the actual maths behind the sequence isn't doubling and tripling. It's indices and the power increasing for every term. Okay, thanks.